When we are looking at points that are plotted on a Cartesian plane, we can say that they are collinear if they lie on the same line. Now, this applies especially if you have more than 2 points. Okay, so if you were given just 2 points as we had on the previous grid, we could easily connect those 2 points with one single line and we could say they were collinear, right? We could make a line that goes through both points. However, if we have more than 2 points and we want to determine if they are collinear, we need to take a look at the slope between each pair of points to see if they actually lie on the same line. Okay, so I'm just going to do a quick little sketch here to show you what I mean, and then I will just erase them and show how to do this algebraically. So obviously, like I said, if we had a point like here and here, I could easily say, okay, those could be collinear because I could draw a line through them, right? Easy, they are collinear. However, if I had a third point, let's say it was over here, now these cannot be collinear because it is impossible for me to draw a single straight line that would connect all three of those points, okay? Because, I mean, these ones are going this way, then I've got like these going this way, they're not on the same line, okay? However, if I were to have, let's say, just these 2 points here, and then maybe I had another point that was here, that one's on the same line, right? So I could say that those are collinear because if I was given just the points and then tried to create a line that connects them, I can do so. Okay, so the way that we do this algebraically, meaning we don't need to plot it because that's time consuming and not necessary, is we want to determine the slope between each pair of points. And if they are the same, then that means that the points are collinear. So when I say pair of points, in this case, I have 3 points, right? I have this point, and this one. So we need to check, okay, what's the slope between, let's say, like the first and the second point? And then you can do either the first and the third point, or the second and the third point. It doesn't really matter which order you kind of put them in, as long as you are checking two slopes between two different pairs of points. Like the pairing is switched up, and if they are the same, then your points are collinear. Okay, so what I'm going to do, I'm going to call this point here A, I'll call this one B, and this one C, just so that when I'm writing, I can show this a little bit easier. Okay, so I'm going to first find the slope between A and B. Okay, again, I could do A and C if I wanted to. It doesn't matter which one I pick. I'm just going to do A and B because that's in alphabetical order. So my slope, I'm going to write this as M1, okay, to indicate that it's my first slope, and then I'll call the next one M2. So I'm going to do y2 minus y1. Again, it doesn't matter which one is 0.1, which one's 0.2, but I'll use b as my 0.2. So I'll have 12 subtract 3, and then I'm going to divide that by -2 subtract 1. Okay, and then now I'm just simplifying, so my slope is going to be 12 minus 3 is 9. On the bottom, -2 subtract 1 is -3. And in this case, so I said to always check and see if your fraction can simplify to a smaller fraction. However, you can also check, does this actually divide out nicely? We can see, does 9 divide by -3? And in this case, yes, it does. If you divide 9 by -3, you just get -3. So my slope between A and B is -3. So if you wanted to write that as a fraction, it would be like -3/1, saying that the line is decreasing. It's going down 3/1. I just like to write it as a whole number if it is one. So we found the slope between A and B. So now I'm going to find the slope between B and C. You could also do A and C, doesn't really matter. And we want to see, is the slope between these points the same, right? So we're kind of saying, okay, like if A is here, we're going down 3 units over 1 unit. B is here. We want to see, okay, from B, if we were to go down 3 units over 1, would that be point C? Okay, obviously it doesn't have to be exactly the next point, like it could be anywhere on the line, but that's what we are checking to see. So I'm going to call this slope m2. And same thing, I'm doing y2 minus y1 over x2 minus x1. So I'm going to do -9 subtract 12, and I'm dividing that by 5, subtract -2. So this is something you need to be careful of when you are finding slope, because you're always subtracting between your two coordinates. Here I was using this C as my second point and B as my first point. So I have -9 subtract 12, that's fine. But then this here, this is a positive, 5 subtract, and in this case my x in my B coordinate is -2, so I'm subtracting -2. So it's important to make sure you put both of those negative signs there, if there is one, so that you calculate correctly. So on the top, I'm going to simplify. Okay, so I'm doing -9 minus 12. If you're unsure how to do this in your head, that's totally fine. Just use a calculator to make sure that you do it correctly. So on top, you're going to have -21. And on the bottom, we're doing 5 subtract -2. So I'm just going to show this over here. When we're doing 5 subtract -2, when you've got two negatives like that, they become a positive. So really, this is equal to 5 plus 2. Okay, so you can kind of either look at it and then recognize that in your head and just do 5 plus 2, or it's totally fine to do it on your calculator. You should have a negative button to type in like 5 subtract -2. So that gives you +7. And again, we're checking, can we simplify this fraction, or can we divide -21 by 7 nicely, which yes, we can. If you divide -21 by 7, you get -3. So look at that, m2, our second slope, is the same as m1. So what we would say then is we would kind of just write like a sentence here, and we can say m1 is equal to m2, so therefore A, B, and C are collinear. Okay, and then if they weren't the same slope, then you would just say m1 does not equal m2, and then therefore A, B, and C are not collinear. They're not all in the same line. But in this case, they are, because my slopes are both the same. If I had have made a pair of A and C, I would have got the same thing. I would have got -3, because again, they're all in the same line. So what I can do with that then is I can figure out the y-intercept of the line as well as the equation of the line. Okay, so I'm going to show you how to do that algebraically, and then that will kind of roll into the next skill that we are going to do. So we know that the slope has to be -3, right? We just calculated that. So we know m equals -3. And again, I'm trying to make an equation like y equals mx plus b. And my y-intercept is going to be b. Okay, so I'm trying to figure out what is b. And in order to be able to do that algebraically, I need to have a value for x and y, so there's only one unknown variable in my equation. So the way that I do this, because I know some points in the line, I know 3 of them, I actually have 3 options for what I can put in for x and y. So I can either put in 1 and 3, I can put in -2 and 12, or I could put in 5 and -9. I'm going to pick point A to plug in, just because those are the smallest and easiest to work with numbers, but it doesn't matter which one you do. So if I use point A, 1, 3, we know that that point is on the line. So I'm going to say that x is 1, y is 3. Okay, so sometimes I write it like this, like where you're just assigning all your variables over there, and then you'll fill them in. I'll also show another method in the next video. So what I'm going to do then is I'm going to rewrite this y equals mx plus b equation, but I'm filling in everything that I know. So I will have 3 is equal to -3 times 1 plus b. Okay, so now I only have one variable unknown, and I can just calculate and isolate. So on the left side, it's still 3. Then on my right side, I have -3 times 1 is -3 plus b. And then I need to isolate for b. So whatever is on the same side of the equation as b, I need to either add or subtract to bring it to the other side. So in this case, it's the -3. So to undo that, I'm going to add 3 to both sides. Right, it's always to both sides to keep it balanced. And then you will have that 6 is equal to b. And that is your fully isolated and solved answer. So we wanted to determine the y-intercept, so we could say therefore the y-intercept is 0, 6. If we wanted to write it as a coordinate, you could also just say is 6, and that's fine. It's just a little bit more proper to write it as a coordinate, 0, 6. And we'd say, and the equation of the line is, and then we can state the equation, because now we know m and b. So when we are writing the general equation, we just write y and x. We don't need to fill in numbers for them because we could use it for any coordinate values x and y. So we're going to say y equals negative 3x, and then we said b is 6, so plus 6. Okay, so this is the y-intercept. This is the equation of the line, and similar to what I said in the previous video, you can use that equation of the line to graph or determine more points algebraically. You can plot it on a graphing software. It's just nice to be able to know what the actual equation of a line is, and in this case then we have 4 points that we know on this line. We know the y-intercept, and then we know points A, B, and C that lie on that line as well.